So modulus inequalities, we will see guys some basic inequalities related to modulus guys. See, modulus mod of x is a positive number. So if I write greater than 0, greater than equal to 0, for what x this would be valid? So guys, any real number if you substitute, let's say -2 you substitute, it will satisfy this. 0 you substitute, it will satisfy this. 1/4 you substitute, 1/4 will also satisfy. Any real number will satisfy. So guys, mod x greater than equal to 0, x is what? So we can say that x is all real. So this is one of the basic inequalities. Mod x is greater than equal to 0 implies x is all real guys. Okay, x belongs to R. So now if suppose mod x mod of fx, if I ask you, greater than equal to 0, then what is x? So mod of fx, let's say fx is any function you can take, linear function, quadratic function. So whatever their domain is, like if I ask x square minus 2x mod greater than equal to 0, so we can say that whatever x we substitute here doesn't matter, it will satisfy. So we can say any x belonging to the domain of the function, whatever the value that we can substitute in the function, any x in domain. We can also say that all x belonging to R. Okay, generally we can say, but in some specific type of questions where the domain is restricted, like if there is, let's say, sine inverse x, for example, if it is written greater than equal to, we cannot say x belongs to R. So we can say that all x belonging to the domain. So fx greater than equal to 0 means what? Any x in the domain. So in this case guys, any x means x belonging to R. Any, because the quadratic function, it can take any real values, any real value can be substituted. That's why all x belonging to R. So x belonging to all those, all x in domain, that we can say that when mod of fx is greater than equal to 0. Again we can take any other example, 3x minus 17 mod greater than equal to 0. Now this is 3x minus 17 is a linear function. Again any value of x can be substituted. So what is the x? Okay, if suppose this is, they are asking what is x, so again this is also an identity because it is valid for all real values. So x belonging to R. Now if I ask you guys, what if mod x is less than equal to 0, what is x? So guys, we know that mod x less than 0 is not possible. Why? Because mod x is a positive number. So this is positive, lesser than 0 is not possible. So mod x less than equal to 0, it basically means mod x equal to 0, it means this. And when mod x is equal to 0 means what? It means x equals to 0 only. So mod x less than equal to 0 means what? X equals to 0. That's it. This is another point. Okay, we can conclude. So in the similar way, if instead of fx x, if it is fx is given, fx mod less than equal to 0, it means what, guys? In the similar way, using the similar reasoning, we can say that mod of fx cannot be less than 0, so at the most it can be equal to 0. It means this. And when fx is equal to 0, for x we have to solve. Okay. So for example, if suppose the question is x square minus 11x less than equal to 0, find the solution of the inequality. Clearly here fx is x square minus 11x. Okay, so we can say that fx equals to 0 is the only possibility. So x square fx equals to 0 we will solve, where fx here in this case is x square minus 11x. So taking x common, we get either x equals to 0 or x minus 11 equals to 0. So there are two solutions, x equals to 0 and 11. Okay, these are the two solutions, which is 0 and 11. Now if suppose mod of x greater than minus a, if they are asking, so mod of x, a is a positive number, like if for example mod x greater than, you can take any number, minus 7, what is x? These kind of inequalities. Now we know that mod of x is a positive quantity, or at the most it can be 0. This is what mod x is. So it will always be greater than minus 7, because minus 7 is negative number. So this whole thing, positive or 0, is greater than minus 7, holds for all x. So we can say that for this x belonging to R. Okay guys, so mod x greater than minus a, in fact even if it is equal to minus a also, still we can say that this is also an identity. We can say that this is x belonging to R. Okay, this is what we can say. So in place of x, if it is fx greater than equal to minus a, then also we can say that x belonging to all x belonging to the domain of fx, belonging to fx domain. What is domain of fx? All possible values of x which can be substituted in fx, so that fx gives what? Fx gives real value. So for example, regarding this domain part, it will be discussed in detail in functions. Okay, so anything we can take 4x plus 5 mod greater than equal to minus 3 by 2, find x. Now since 4x plus 5, any value can be substituted, this is because this is a linear function, so we can directly conclude that the solution of this is what? X belongs to R, or x belongs to minus infinity to plus infinity. Okay, now if for example, now if they ask mod x less than minus a, where a is positive, for example if I ask you mod x less than minus 12 for what x, then what you will say, guys? So in that case, this we will use the reasoning, this is positive or 0, Now positive or 0 is lesser than minus 12 is not possible. This is wrong. It can never be lesser than minus 12. So we can say that no x is possible. Or we can say that x, no solution x belongs to phi. Okay. So when mod x is less than minus a, which is not possible, so we can directly say x is phi, or no solution, or no x is possible, guys. Okay. Now in the similar way, if they are, for example, now instead of x, if I take some x like x square minus x minus 9, okay, less than minus 3. So again, x square minus x minus 9, whatever you x is substituted here, this x square minus x minus 9, the modulus will give positive value or 0. So lesser than minus 3 doesn't hold. This will never be less than minus 3. So here also we can say that x is phi, or we can say this equation is inconsistent, or it has no solution. Okay. Now if suppose the question is, the situation is like this: mod x is less than a, where a is a positive number. So now again you can see, now again you see that this mod x is positive. Positive is, a is positive, so positive is less than positive. So this can happen. Okay, this can be true depending on x. For example, if I ask you what is mod x is less than 7, if I say x equals to minus 3, if you substitute minus 3 mod less than 7, 3 less than 7 holds true. This is true. So x equals to minus 3 is a solution. Okay. So x equals to minus. So in the similar way, there may exist other solutions as well. So the question is, how do we get the solution of this kind of situation, this kind of inequality, mod x less than a or less than equal to a, guys? Okay. So mod x less than a or less than equal to a. Okay. So let's understand this, how we can treat this. Now mod x less than a or less than equal to a. But since both are positive, we know from the rules of inequality, we can square both sides. So when you square both sides, mod x square. Now before getting to this part, I would like to ask you a few things regarding this. One question I will ask you, like if mod x square oh, what happened? So if suppose mod x square mod, okay, and x square, what is the relation between these three? Are they same, or is there a difference? X square mod x square mod. So guys, yes, they are same. Okay, mod x square, you take mod and take square, do square, you do square and then you take mod, and then square. Every time the answer would be the same. Okay, like for example minus 2 square, minus 2 mod square, 2 square mod. So this is 4. This is 2 mod, minus 2 mod is 2, 2 square is 4, 2 square mod 4 of 4 is 4. Okay. Now coming back to the next inequality, which I asked mod x less than equal to a, x is positive, sorry, mod x is positive, a is positive. So definitely we, in the previous example we saw that some solutions were there. Now in order to find the full solution, the exhaustive range of solutions, how do we solve this? So we know from inequalities that if both the numbers are positive, we can square both sides. So when you square both sides, this mod x square less than equal to a square it becomes, and mod x square we know that it is x square less than equal to a square. Okay, so as you can see here that mod x less than equal to a, this system is similar to x square less than equal to a square. So whatever the solution of x square less than equal to a square we have or we know, the same would be for mod x less than equal to a. So we know that x square less than equal to a square, the solution was what? It was x minus a to a. Okay, from inequalities, so we can say that mod x less than equal to a, the solution is x minus a greater than equal to minus a less than equal to a. Now if equality is not here, if the equality is not here, it won't be here, and if equality is present, it would be present here as well as here. Okay, so for example, mod of x less than equal to 7, so this system is equal to x square less than equal to 7 square. So we can say that x is from minus 7 to plus 7. X belongs to minus 7 to plus 7, both included, is the solution of mod x less than equal to 7. Okay. If you try this 11 of mod x minus 2 less than 0, what is x? Try this. So again guys, we will solve this. You will take minus 2 on the right hand side, it becomes plus 2. 11 we will divide, 11 we will take on the right hand side denominator, so this becomes 2 by 11. So this is what? 2 by 11 is a, mod x less than a, x is minus a which is minus 2 by 11 to plus a which is plus 2 by 11. That is the answer guys. Okay, so what if instead of x, if it is fx less than equal to a, how do we get x? How do we proceed in this? So guys, yes, the same. If you square this system is equivalent to this. F square x is less than equal to a square. Okay, so which gives fx minus a to plus a. We can also say that fx, okay, and so on. We can, in the next step, we can split it into two if required. Fx greater than equal to minus a, fx less than equal to a, when we will take the intersection of that if required. So let's take an example on this. 3x minus 1 less than equal to 5. Solve for x. So guys, as you can see here, we can, this is fx is 3x minus 1 here. Okay, so we can write fx minus a to a. This we can use directly here because this situation is similar to f square x less than equal to a square. So we can directly write in the next step minus 3x minus 1 between minus 5. A is 5 here. A is 5 here. So minus a is minus 5 to plus a plus 5. Now we can solve this inequality. We will add 1 both sides. Okay. So these two gets cancelled. 5 plus 1. So this becomes minus 4. 3x less than equal to 6. Now we will multiply by 1 by 3. So it becomes minus 4 by 3. This becomes x and this becomes 2. That would be the answer, minus 4 by 3 to 2, guys. Okay. Now try this example, guys. If x square minus 3x mod less than root 2, find x. How you will solve this, guys? Squaring root 2, it becomes more, calculation would be more. Let's say it's 2 only, guys. So again, in the solution part, because hint would be the same, this would be fx. So this would be fx. So fx would be between minus 2 to plus 2. So fx, which is minus x square minus 3x, would be minus 2 to plus 2 from here. Okay, mod fx less than equal to a. So fx minus a to plus a we can directly write. In the next step, we can again split it into two inequalities and take their intersection like this. So minus 2 x square minus 3x comma, since it's not linear, we cannot solve it simultaneously, so we will split it into two inequalities. Comma means we have to take the intersection of whatever we get after solving these two inequalities. Minus 2 we will take. Now we will separately solve each one of them. Another is x square minus 3x minus 2 less than equal to 0, guys. Okay, now x square minus 3x plus 2, we will factorize x square minus 3x minus 2 also we will factorize. Okay, that would be the first step, and then we will use wavy curve and find the intersection of these two inequalities. So let's say this is first, this is second. We will solve first quadratic inequality. So we can x square minus 2x minus x plus 2 greater than equal to 0, taking x common, minus x minus 2, x minus 2 into x minus 1 greater than equal to 0. So using wavy curve method, these two zeros which are 1 and 2, 1 corresponds to x minus 1, 2 corresponds to x minus 2, plus minus plus, it gives, since plus greater than equal to, they are asking plus sign we will take, so it would be minus infinity to 1 union 2 to infinity. This is the result of first quadratic inequality. Now moving on to the second quadratic, which is x square minus 3x minus 2 less than equal to 0. So we will solve the second one x square minus 3x minus 2 less than equal to 0. So as you will observe that factorizing using splitting the middle term won't be possible. So we will use quadratic formula x equals to minus b plus minus under root b square minus 4ac upon 2a, where a is the coefficient of x square which is 1, b is coefficient of x which is minus 3, and c is constant coefficient which is minus 2. That we will substitute here. So minus of minus 3 plus minus b square minus 3 square minus 4 into 1 into minus 2 upon 2a. So which gives us x equals to 3 plus minus 3 3s are 9 plus 4 2s are 8 by 2. X equals to 3 plus root 17 by 2, 9 plus 8 is 17. Another is 3 minus root 17 by 2. So root 16 is 4. So this is 4.1 approx. Okay, root 17 is approximately equal to 4.1. Okay, so this becomes what? 4.1 plus 3, 7.1 by 2 approximately equal to, and this becomes 3 minus 4.1 by 2. So this is x is 72, 3 is 3.6 approx, and this is minus 0.4 approx, minus 0.45 we can say that. So x square minus 3x minus 2 less than equal to 0, it is factorized as this minus 4.45 less than equal to 0. So we can use Vivicar method. We will use plot the zeros, which is one of them is minus 0.45 and another is 3.6 plus minus plus. We will take minus. This is the second result. Now plotting the first result. The first result was this. Okay, that we will, the first result that we will write minus infinity to 1 union 2 to infinity. We will write here and take the intersection of first and second. Okay, so first we will write 1 would be somewhere around here, lesser than 1, 2 is here. Okay, 1 to minus infinity to 1, 2 to infinity. In both the questions, why we are taking and, I hope you understand, because of this comma sign. Okay, first and second we need to take intersection. Here greater than equal to 0 was there, so 1 and 2 will also be included in the solution, and so would be for the second inequality. So this will also be there. Now if you take intersection from here to here, here to here there is common, and again from 2 to 3.6 there is common. So that region, that length of interval from here to here, from here to here would be our solution, which is minus 0.45 to 1. Here 1 and 2 was included, and then 2 to 3.6. But we know that minus 0.45 was 3 minus root 17 by 2, and 3.6 was 3 plus root 17 by 2. Okay, here also they will be included, all will be included, guys. So the answer would be what, guys? Minus 0.45 to 1 union 2 to 3.6, which can be written as x belonging to 3 minus root 17 by 2, which would be included. So square bracket comma 1, again square bracket closed, union 2 square bracket to 3.6, which is 3 plus root 17 by 2 closed. Okay guys, now the next type of inequality should be what? Mod x. What else is left? So mod x greater than equal to a is left now, or greater than a. Now since again here if both are positive, positive is greater than positive may hold for some a, for some x. For example, if I ask you mod x greater than equal to 3 by 2, x equals to minus 1, 3, they all satisfy this. Okay, so the question arises, how do we solve this? Is there the same method that we use, same concept that we use to solve for mod x less than a or less than equal to a? So yes, the answer is same guys. Mod x greater than equal to a, using inequality property, if we square both sides, this will give x square greater than a square. So whatever the solution of x square greater than a square, the same would be for mod x greater than equal to a. And we know that x square greater than a square from inequality, the solution is x greater than equal to a or x less than equal to minus a. So for mod x greater than equal to a, solution is same as x square greater than equal to a square, which is this. Okay, so it means what? If you take any simple example, let's say 3 into mod x minus 4 greater than 0. So we can say that 3 of mod x is greater than 4. Now 3 we will divide, so it becomes mod x greater than 4 by 3. So we will use the formula x greater than 4 by 3 or x lesser than minus 4 by 3. Okay, that is the solution. We can write it in interval form also. Okay, had the question consist of equality here, then here also equality would be there. Okay guys, so if I ask you, let's try this. 4x minus 1 mod greater than equal to 2, find x. Now instead of x I have taken fx. So we know that this system is equivalent to this 4x minus 1 whole square greater than equal to 2 square. Okay, so which we can take on the left hand side, or directly we can write it as fx, which is 4x minus 1 greater than equal to a is 2 here, or 4x minus 1 is less than equal to minus a. So whatever the two equations, now the two equations that we got, we will take what? We will take OR. So taking minus 1 on the right hand side, this becomes 3. Dividing it by 4, this becomes 3 by 4. Here also taking minus 1 on the right hand side becomes minus 1. Dividing it by 4, this becomes x less than equal to minus 1 by 4. OR means union. Okay guys, so x less than equal to minus 1 by 4. So that's the answer to this question guys. So guys, let's try this. So quite clearly, if we think we can use this mod of f less than a, where a is 3, and f is this whole rational function 8x upon x square minus 1, and we can square both sides, f square less than a square. Okay, this is the first method, and then we can use factorization, factorize f minus af plus a, and so on and solve. So using this first method, f square minus a square. Now before that, what we can do, we can split this 8x mod 8x upon mod x square minus 1. We can write it like this, less than equal to 3, using this mod a upon mod b, which is equal to whole of a by b mod. Okay, and now 8x mod, can we cross multiply x square minus 1 this side? So answer is yes, we can cross multiply. Why? Because mod is positive, but since x square minus 1 is in the denominator, x square minus 1 shouldn't be 0, so x square shouldn't be 1, so obviously x should not be plus minus 1. So 1 and minus 1 we will exclude in case if it comes after solving. Now what we can do, we can square both sides. So 8x mod square less than 3 mod x square minus 1 square 3 square. Okay, so mod x is 8x square, we will take this side on right hand side, so this we will take here, and 3, this mod we can write in the form of bracket also, and 3 I can take inside, that I will do in the next step, 8x square. So we can write this as 3, if it goes inside it goes as 3 because square is here, minus 8x whole square. So which formula we can use? Yes, we can use this 3x square minus 1 minus 8x, a minus b, a plus b. So a minus b is this, and a plus b is this. So guys, so 3x square minus 3 minus 8x. So 3x square, 3 3s are 9. So minus 8x can be written as minus 9x plus x minus 3. So minus 8x we wrote as minus x plus x. Okay, now here 3x square plus 8x we will write as 9 minus 1 x. So plus 9x minus x minus 3 as it is. So now we can take 3x common from here. Okay, and x minus 3 as usual. 3x, taking 3x common, we will get x minus 3 plus x minus 3 as usual. Again we will take 3x common from here, so x plus 3, taking minus 1 common, so again x plus 3, like that it will go. So x minus 3 we can take out, inside we would be left with 3x plus 1. Here we will take x plus 3 out in the second. Okay, taking x plus 3 out, so it is this, and we are left with 3x minus 1 inside, guys. So we will use wavy curve method, guys. So there are 4 as you can see, there are 4 zeros here. x, the biggest one is x minus 3, x minus 3, so 3 we will plot, followed by 3x minus 1, so 1 by 3 we will plot, again followed by x plus 3, sorry 3x minus plus 1, which gives minus 1 by 3 as one of the 0, and followed by x plus 3, which gives minus 3. All have odd powers, so plus minus moving leftwards, plus minus plus, and the question is asking for greater than equal to 0, means plus we need to take, so plus values here, here, and here we will take minus infinity to minus 3 as one set. Equality is there, so we will take equality everywhere, minus 3, minus 1 by 3, plus 1 by 3, plus 3, then minus 1 by 3 to 1 by 3, then 3 to infinity. So it is, guys, x belongs to minus infinity to minus 3 closed, union minus 1 by 3 to 1 by 3, union 3 to infinity is the answer, guys. Now, what if the question, we have seen mod x less than b, we also saw mod x greater than a or greater than equal to a. What if the question is, guys, a combination of these two, means this a to b, where a is lesser than b, a and b are positive. What I mean to say is mod x, for example, if they ask what is the solution of mod x 3 to 7, mod x 1 by 2 to 5 by 3, and so on, these kind of questions where mod x is sandwiched between greater and less than signs. So this kind of inequality, modulus inequality, if we encounter, how do we deal with it? So yes, the concept is the same. We can square both sides. Okay, so if you square both sides, you will get x a square, x square, b square, and from inequalities chapter we know that the solution of x square between a square and b square is minus b to minus a union x a to b. And in case if equality is at the site of a square, so wherever there is a or minus a, that side will place equality as well. If the equality is on both, so we will place equality everywhere. So this is the, the solution of mod x a to b, okay, is this union this, which is x a to b or x minus b to minus a. Okay, so this is next rule that we can use. And in the same way, if suppose x instead of x, if suppose we can generalize it also, if fx is there, that also we will see, but let's see one basic example first. Mod x 2 to 5, find x. So guys, directly we can write the answer, x minus 5, which is minus b. See, this is a and this is b, both are positive, b is greater than a. So minus 5 to minus 2, directly you can write union 2 to 5. Now equality is here, okay, so we will place equality at -2 and +2. Okay guys, now if suppose instead of x, let's say if there is fx like this, so if it is like this guys, if instead of x, if it is fx mod a to b, fx is between mod a to b, then fx is a to b, or fx is minus b to minus a. For example, if I ask you 2x minus 1, 1 to 4, solve this. Okay, so directly we can use this result as our solution using the formula here. This is fx, this is a, this is b. So we can directly use the formula fx minus b2, which is minus 4, to minus a, which is minus 1, union fx a to b. Okay, so 1 to 4. Okay, now we will solve these two results. So solving this, these two will add plus 1 both sides. So we will get minus 4 plus 1, 2x minus 1 plus 1, minus 1 plus 1. Here also adding 1. So this becomes 1 plus 1, 2x minus 1 plus 1 less than equal to 4 plus 1. This cancels out, minus 1 plus 1 cancels out. We are left with minus 3 less than equal to 2x less than equal to 0. And here we are left with 2x between 2 to 5. Now again multiplying by what to get x? So multiplying by half. So it gives you what? Minus 3 by 2 x 0 or x 1 to 5 by 2. Okay guys. Now let's take another example. What if the question is like this? 3x plus 7 greater than equal to minus 2 less than 14. How we can approach this? So guys, can we use the formula a to b, the same formula that we did? So yes, answer is no. Why? Because here this is a, which is negative, so the formula cannot be used. So then how we can proceed? So we can proceed like this guys. We can split this into 2. 3x plus 7 greater than equal to minus 2 mod, and which is represented by comma 3x plus 7 mod less than 14. Now this, we know that this is an identity because this value is always positive or at the max 0, which will always be greater than minus 2. So the solution of this is x belongs to R, this particular inequality. Now if you solve this, we will use mod x less than a result, which is minus a to a. Here x is fx guys. So 3x plus 7 minus 14 to plus 14 guys. That way we will solve. So adding minus 7 minus 14 minus 7, 3x plus 7 minus 7 cancels out, 14 minus 7 minus 21, 3x 7. So multiplying by 1 by 3, it is minus 7 x. Okay, so 21 by 3 is minus 7, 7 by 3. Okay, now here we got x belongs to R. So x belongs to R. intersection with minus 7, x belongs to R, intersection with minus 7 to 7 by 3 is what, guys? So yes, it is, answer is minus 7 to 7 by 3 only, guys. Let's take another example. Mod of x minus 1 minus 2 whole mod greater than 3. Okay. Solve for x. Okay. So what we will do, this is fx. This is fx. So fx greater than equal to greater than a we will use. Okay. So which is fx greater than a means what? Fx greater than a, mod fx greater than a means fx greater than a or fx let's change this question a bit, guys. Instead of greater, I will place equal to sign, less than. So fx mod fx less than a means what, guys? Fx is minus a, this is a, guys, minus a to plus a. Okay, so let's say this is 12. Now adding 12 plus 12 both sides, 12 minus 3 mod x minus 1 minus 12 plus 12 cancels out, 3 plus 12, this becomes 9 mod x minus 1 less than 15. So now we will use the formula fx, this is a, this is b, and this is fx. So fx means x minus 1 from a to b, which is 9 to 15 union x minus 1 minus b, which is minus 15, to minus a, which is minus 9. So adding plus 1 in both the inequalities, 9 becomes 10, minus 1 plus 1 cancels out, this becomes 15 plus 1 16, union minus 1, this becomes minus 14x, this becomes minus 8. So the answer is x belongs to minus 14 to minus 8 union 10 to 16, guys. Okay, is the answer. Okay, so that way we can do. Now moving on to few more inequalities, guys. Few more inequalities and identities in modulus. Few more identities in modulus inequalities. Instead of identities, it's better to write few more results. Okay, few more results. So now let's move on to this. If a and b are two numbers, and if I take mod and add them, and if I separately add the two numbers and then I take mod, what do you think, which sign should come here? Greater than, less than, greater than, equal to, less than, equal to, what should come here, guys? So guys, a, let's take a as minus 2, b as minus 5. So mod a plus mod b, that becomes 2 plus 5, and a plus b, let's say this is 5, guys. So a plus b is what? Minus 2 plus 5, it gives you 3. So guys, as you can see here, this sign should be greater than sign should come. Now if you take same sign value, a as -2, -5, a as 2 and 5, and all those combinations, you'll say equality will also hold. Okay, so guys, using some basic substitutions, verification of a and b, we can say that this is greater than equal to a plus b for all a b belongs to what? So this is one of the identities in modulus inequalities, guys. Okay, so for example, if I ask you mod x minus 1 plus 2x minus 1 greater than equal to 3x minus 2 for what x? So the thing is, guys, if you compare this with the result, if this is a, this is b, as you can see, if you add a plus b, 2x and x, if they gets added and they will give 3x, minus 1 gets added, they will give -2. So this is of the form, this is resembling the identity that we saw, mod a plus mod b is greater than equal to mod a plus b. So since it is valid for all a and b, okay, so x minus 1 is r, 2x minus 1 is any value. Okay, so x is any value. From this we say, and this also we can say x is any value. So it's an identity, it is valid for all x belonging to R. Okay, so now if suppose if I ask you mod a plus mod b less than a plus b, are there any values for which this holds? So if you take different signs combination, plus plus minus plus, plus minus 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 and so on, okay, -2 b, you take -7, this becomes mod to -2 which is +2, mod of -7 which is +7, this is 9, this won't hold. In fact, any combination you write, even if you take 0 0 also, it won't hold. So if this is written and they are asking what is a and b, okay, so we can say that a and b are nothing, a and b, no a and b possible, we can say. Okay, so like for example, in the same question, if I ask you instead of greater than equal to, if the question is less than, if they ask less than, so guys, what we can say, what we can comment about a and b, which is x, what x will, which x will hold, guys? So since this is following this lesser than, so no x possible, or x belongs to phi also, we can say that, we can say. Okay, now the question arises, what if it is given as mod a plus mod b equal to a plus b? Okay, then what is a and b? What are a and b? A and b are some real numbers, of course, but here what they want to ask is what are a and b, means what are the signs of a and b. So as you can see here, if I take a as -7, b as -1, or any other combination like a as 4/3, b as 6/11, both negative I took in the first case, in the second case both positive I took. Like if you take both negative, -7 mod plus -1 mod minus 7 minus 1 mod 7 plus 1 equals to 8. This is satisfying. So what we can infer, what we can conclude from this, that if a mod plus b mod is equal to a plus b mod, what do you think a and b should be? So guys, we can say that a and b are of both, yeah, either both plus or both minus, or collectively these two can be written as a b greater than equal to 0. Why equal to 0? Because if you take any one to be 0, like if you take b is equal to 0, still it will satisfy. Okay, so if any one or both are 0, then also it will satisfy. So if mod a plus mod b is equal to a plus b mod, it implies what, guys? It implies ab is greater than equal to 0. This is what we can conclude. Okay, so let's take another question. Mod x plus 3x minus 1 is equal to 4x minus 1. Find x which satisfies this, guys. So as you can see here, if you inspect, if you check, then you will observe that this fits into this rule, mod a plus mod b is equal to mod a plus b, because if you add x plus 3x minus 1, 3x minus 1, you will get 4x minus 1 only. So therefore we can say that AB has to be greater than equal to 0, where A is x and B is 3x minus 1. So x into 3x minus 1 greater than equal to 0. The solution of this using wavy curve would be the solution of this question, plus minus plus. The question is asking for plus, so we will take plus sign, intervals, this, which is minus infinity to 0. Equalities hold, so 0 will take 1 by 3, we will take 1 by 3 to infinity. That would be the answer, guys. Okay. Now, what if the same question I frame to be like this: mod x plus 3x minus 1, mod 3x minus 1 is less than equal to 4x minus 1 mod. Now if I ask you what x is, find x which satisfies this. Now again it fits into this kind of thing, which is if I take x as a and 3x minus 1 as b, so mod a plus mod b, if you add these two, it is similar as the previous example. So mod less than a plus b. Now we know that mod a plus mod b less than doesn't have any solution. Okay, so in the next step, the only possibility is we can write it like this: mod a plus mod b is equal to a plus b, because less than is not possible. So this is the only choice, only possibility, and which leads this question to the previous question that we did, which is this, the above question, this one. Okay, so this question and this question, basically they are same, so the answer is again the same. Okay, the answer to this question would be same as this, because this question is same as the previous question. Okay guys, now I will give you another question: x square plus x whole mod plus x plus 1 x square minus x minus 1. Okay, x square minus 3x plus 2, let's take guys, is equal to 4x minus 2. Find x guys. Now how you will solve this guys? So does this question fits into this, the question? Okay, does this question fits into mod a plus mod b equals to a plus b mod? So guys, if you consider a as x square plus x, b as x square minus 3x plus 2, and adding these two, you won't get what is given in the right hand side. Okay, but if you look at it closely, the difference of these two, the difference of a and b is what is given in the right hand side. So you can do a little simple manipulation. X square plus x, which was the same, x square minus 3x plus 2, you can write it as x square minus 3x plus 2 minus times, because we know that mod of fx is minus fx mod. Okay, and now you can see x square plus x plus 3x minus 2 minus x square, which is this if you solve. What I mean to say is, this a is okay, the b is not the same. B has to be this minus times of this, so that it fits into a plus b. It makes the right hand side modulus a plus b. Okay, because if you solve this x square plus x plus 3x minus 2 minus x square, it gives you 4x minus 2. Okay, so a is same, b is you multiply by minus 1 and then you consider it as b, so it will fit into that identity, that formula mod a plus mod b is equal to a plus b mod. So now we can write a b greater than equal to 0, where a is what, x square plus x, and b is what guys, minus x square minus plus 3x minus 2 greater than equal to 0. So now we need to simply solve this. Now if you factorize this, if you take minus 1 common, x square minus 3x plus 2 can easily be factorized into two linear factors, one of which is x minus 1, another is x minus 2 greater than equal to 0. Now you will use baby curve method. There are 4 zeros that we will plot. The biggest 0 is x minus 2, related to that 0 is 2, followed by x minus 1, the 0 is 1, then again the next one is x plus 1, which is minus 1, it should be here, and then related to this x, it is 0. And now since there is minus sign here, minus x, so the rightmost interval we will start with which sign guys? Yes, from baby curve method we will start with negative sign instead of plus sign, and while moving leftward this becomes plus, then minus, then plus, then minus. Equality, the question is also asking for equality, so we will take all the zeros in our solution set. minus 1, 0, 1 and 2, and then the question is asking for plus sign. So what we will do, guys, we will join minus 1 and 0, we will join 1 and 2. So the answer would be from minus 1 to 0 union 1 to 2 both included, which can be written like this: x belongs to minus 1 to 0 union 1 comma 2. That way we can do, guys. Now using a similar concept, similar thinking, if I ask you another question, now solve for x, how you can attempt this? Does it fit into what we already did, or this requires a bit of thinking? Although on the same lines we will think. Okay, so how we can do this, guys? So guys, as you can see here, if we consider this to be a, this to be b, so this becomes mod a, this becomes mod b minus mod b. Now if you carefully observe, x plus 2 is basically 2x plus 3 minus of x plus 1. So we can write this as what? We can write this as minus x plus 1, okay, minus of minus 2x minus 3. We can write this in the next step. So as you can see here, this is a, which is plus x plus 1, b is 2x plus 3 mod, is written as x plus 1 is written as what? Minus x plus 1, 2x plus 3 mod is written as minus 2x plus 3, which means that x plus 1 is minus x plus 1 written, and 2x plus 3 is written as minus 2x plus 3, which means what? Which from here it means x plus 1 should be what? Negative. And from here we can say what? A 2x plus 3 should be what? From the definition of modulus, it also should be negative, because after removing the vertical bars we will get negative sign. Here also the same, we are getting negative sign. So x plus 1 should be negative and 2x plus 3 should be negative. We will take the intersection and of these two, which would be the final answer, guys. So x plus 1 less than 0 gives x less than minus 1. 2x plus 3 gives 2x less than minus 3, which gives x less than minus 3 by 2. Taking intersection of x less than minus 1 and x less than minus 3 by 2, which is on the left side of minus 1. If you take intersection, you will get what? X less than minus 3 by 2 as our answer. Okay, guys. So that way we can do. So guys, let's try this. Under root of x minus 1 minus 2 times under root of x minus 2 plus under root of x plus 2 minus 4 under root of x minus 2 equals to 1. Solve for x, find x. How we can proceed with this? So guys, in order to remove this under root, guys, as well as this under root, we have to think like their approach would be to make this term and this term in perfect square, so that if it comes out to be like this, if it is represented like fx square, so it is removed and it becomes this. So we will do some rearrangement here. Okay, the first term, which is, so directly heading towards the solution, x minus 1 we can write as x minus 2 plus 1. Okay, so this minus 1 is written as minus 2 plus 1, guys. Minus 2 under root x minus 2 as it is. Here also x minus 2 we will write. So to balance out we will write plus 4. So this plus 2 we can say is written as minus 2 plus 4. Okay. Minus 4 under root of x minus 2. So in the next step, guys, we can write this x minus 2 as under root of x minus 2 whole square. This 1 we can write as 1 square minus 2 into 1 into under root of x minus 2 we can write. So this term can be written like this. Okay. Plus under root of this, the second term now. The second term, x minus 2 we can write again as under root of x minus 2 whole square. 4 is written as 2 square minus 4 is written as 2 into 2 under root x minus 2. So this 4 we have written as 2 into 2. Okay. So guys, this is of the form a square plus b square minus 2ab. So which can be written as root x minus 2 minus 1 whole square, plus similarly the second one also fits into a square plus b square minus 2a into b. So it is a minus b whole square. So a is root x minus 2, b is 2. So a minus b whole square. So we know that under root of a square is mod a. So we can write it as root of x minus 2 minus 1. And this also we can write as root of x minus 2 minus 2 equals to 1. 1 is the right hand side. So guys, if you rearrange it like this, root x minus 2 minus 1, this first term as it is, the second term if I multiply inside by minus times, doesn't matter. Okay, because from here to here, if you can write, we know that mod of f is equal to f minus f mod. So we can write it as 2 minus root x minus 2. So this one I can write as mod of root x minus 2 minus 1 plus 2 minus under root x minus 2. This one I have written like this, guys. So as you can see here, you can, if you name it as a, if you name this term as b, so this is mod a plus mod b. So this term would be what? This would be a plus b mod, which we guys know is what? The solution of this is ab greater than equal to 0. So guys, a is root x minus 2 minus 1 into 2 minus root x minus 2 greater than equal to 0, guys. Okay. To create an effect of something like it should look like a wavy curve question, let's replace root x minus 2 is t, which is only for representation purpose. Otherwise, conceptually, it doesn't serve any purpose. So this we can write like this, greater than equal to 0. Now we will plot the zeros. One of the zeros is 1, the 0 of corresponding to 2 minus 2, 2 minus t is 2. Now since the coefficient is negative here, we will start with the rightmost interval by minus sign, and proceeding on the left hand side we will put plus and then minus. Now the question is asking for greater than equal to, so equal to we will mark 2 and mark 1, and then we will join 1 and 2, guys. Okay, so this is t between 1 and 2, guys. Okay, now t between 1 and 2, but t is what? Under root of x minus 2. So that we will write. Now we can square both sides because all the three terms here are positive, so we can square all the three sides of the inequality. So 1 square, under root is removed, it becomes x minus 2. Here also 2 becomes 2 square. So 1 to 4, x minus 2 lies between 1 to 4, adding plus 2, we will get 3 x, 4 plus 2 is 6. So 3 to 6 is the answer, guys. Okay, and root x minus 2, while writing this as root x minus 2, we it was implied, we inherently suppose that this should be positive. X minus 2 should be greater than equal to 0. That is the domain constraint. X greater than equal to 2 is already satisfied by this answer. So this is what we can take as our final answer, 3 to 6. Okay, so let's take another question from mains 21. A, B, C are three sets. A is such that x belongs to R. A is satisfying this inequality mod x minus 2 greater than 1. B is another set satisfying under root of x square minus 3 greater than 1. And C is an inequality satisfying mod x minus 4 greater than equal to 2. Then we have to find the number of subsets of A intersection B intersection C whole complement intersection Z, where Z is set of integers. Okay, so let's try to understand the meaning of this, guys. Okay, so guys, the meaning is meaning and approach. Meaning means we have to, the three sets that are given, we have to solve the inequality, and then we have to uh, take their intersection of A and B and C. We have to take intersection, and then from that we will find the complement. After finding this set, we will take whatever we get, we will take its intersection with set of integers. Now after set of integers, let's say after taking this intersection with z, let's say for example the number came out to be let's say 3 for example. So number of subsets, we know that it is 2 to the power n. So we will use from the set theory, number of subsets would be 2 cube. So let's say if it is any number n, if it comes out to be, then the number of subsets would be n. This is the answer. So that's how we will approach. So first we will find this A, and then we'll find B, we will find C, and we will take their intersection. So this is the meaning and approach, or we can say hint of this problem. That way we can do. Right, guys? So let's now go for the solution. So first we will find A. So A is what, guys? As you can see, A is mod x minus 2. A is given to be mod x minus 2 greater than 1. So that we will solve. Okay, so mod x minus 2 greater than 1. So for that we will use mod of fx greater than a, which is what? F greater than a or lesser than minus a. Okay, so f is x minus 2 here, so x minus 2 greater than 1 where a is 1, or x minus 2 is lesser than minus 1. So x greater than 3 it becomes, or x less than 1 it becomes, guys. Okay, so let's say this is 1. Now we will solve for B, set B. Set B is the solution of inequality under root of x square minus 3 greater than 1. So under root of x square minus 3 greater than 1, obviously the domain constraint must be satisfied, which means x square minus 3 must be greater than equal to 0, x square must be greater than equal to 3. Okay, now after considering the domain, we will square both sides, so the under root is removed and this is 1. Now adding plus 3 both sides, we will get x square is equal to is greater than 4. Okay, which we can write as 2 square. So x square greater than 2 square, we know that x square greater than a square from inequality is x greater than a or x less than minus a, where a in this case is 2. So we will write this solution as x greater than 2 or x less than minus 2. This is set B. Okay, so first set x greater than 3 or x less than 1. Let's say this is second. Okay, now the third one, the set C. Set C, they are asking for mod x minus 4 greater than equal to 2. So we will use the same formula that we used in set A, which is this mod fx greater than a, f is greater than or less than minus a. So in set C, which is x minus 4 greater than equal to 2, greater than equal to 2, we can directly write x minus 4 greater than equal to 2 or x minus 4 less than equal to minus 2. Adding plus 4 on both sides of the inequality, this becomes 2 becomes 6. Here also adding 4, this becomes 2. Okay, so this is the third inequality set. Okay, guys. So guys, we can plot this, the third one, as this. Greater than x greater than equal to 6. So we will plot 6 and greater than 6 on the right side, 6 to infinity. 6 would be included. Now plotting x less than equal to 2. This is 2, and then we will plot it like this, lesser than 2 minus infinity to 2. This is the third inequality. Similarly, the second and the first we will write and plot. Okay, like this. So first and second also we will plot. The second one is x greater than 2. So greater than 2 is 2 and greater than 2 would be this. Okay, less than minus 2. So less than minus 2 would be like this. Okay, now the first one we will plot x greater than 3. So x greater than 3, 3 would be here like this, and x less than 1. So 1 we will plot. 1 is somewhere here. Okay, like this, minus infinity to 1. Now if you take the intersection, because first intersection, second intersection, third, which is what A intersection B intersection C is. Okay, so if you see here onwards and here on, after 6, all the three have common solutions, and lesser than minus 2 here as well as here as well as here, they have common solution. So guys, our intersection A intersection B intersection C is what, guys? A intersection B intersection C is minus infinity to minus 2. Okay, to 6 to infinity. So guys, the intersection, as you can see here, 6 is here present, it is present here, it is present here. So in the intersection, 6 will be present here also. Now if we take A intersection B intersection C whole complement if we take, so whatever we are left with, this portion would be our complement. So minus 2 is not present, so minus 2 we will take to 6. 6 is present, so 6 we won't take. So minus 2 to 6 is A intersection B intersection C whole complement. Now Z, the set of integers, is minus 3, minus 2, minus 1, 6, 7 and so on. If you take intersection, this is what they are asking. So if you take intersection, you can see the intersection is minus 2, okay, minus 1, 0, 1, 2, 3, 4, 5, 6 won't be there because 6 is not here. So we won't take 6. Okay, so minus 2 onwards, minus 1 till 5 we will take. So if you count minus 2 to 5, 5, 6, 7, 8, 8 is the value of A intersection B intersection C whole complement intersection Z is 8, guys. Now they are asking, next is number of subsets. So number of subsets means 2 to the power 8, okay, which is, okay, 256. So that's the answer.